Hi, I'm Alistair, and we'll be going through the week 4 notebook from the Cross Society Python course, which is run by the UWCS Society, CodeSoc, and Warwick AI. So this week we were looking at various methods of taking input into our Python application and the challenges that come with that. So in this lecture, we're going to kind of look at file reading, file writing, command line arguments, and libraries. So the reason for this is all of these sort of things are very useful ways of kind of extending functionality of our program and giving our program longevity as well. So before this week, all of our programs have only been able to deal with data that was kind of given to them while they were running. As soon as the program closes, all of the data was lost, so you can't really keep anything saved between runs of the program. So the reason why we need stuff like file reading and file writing is that when we create these programs, we want them to be able to store data between restarts. So, for example, if you're writing a document in Word, let's say you're writing an essay, you don't want that essay to be deleted once you close Word. You want it to save the progress, and then you can open it back up later, carry on working. So we want our programs to be able to like sort of deal with data that we can save on our computers, and then open up again and carry on processing or carry on using. So the first part of this is going to be looking at file reading. So to read from a file, we need a file to read from. So if you're following along with the notebook, if you're coding along there, create a file in the same folder as a notebook called test.txt and just add some text to it. I've already done this here. You can see it just says this is a test message. So what we're going to do is we're going to read this file into Python. And to do this, we need to first open the file. And we use the open function for this. And this takes two arguments. It takes file path and mode. The file path is like the relative or absolute path of the file. Basically, it tells Python where the file is on your computer. The next argument covers the mode in which you want to open the file. So do we want to write to the file? Do we want to read from the file? Do we want to append to the file? In this case, we're going to use read arm. So I'm going to call it test file equals open data slash test txt. If you look over here, you can see that test.txt is within the data folder in the directory. And then comma there, and then R to tell Python that we're going to read from the file. So we're going to go ahead and run that. And then to read from the file, we call the read method on the file. So I'm just going to store our data in a variable called data, and then we test file.read. And what this is going to do is this is going to open up test file. So we already opened test file. It's going to take test file. It's going to read everything that's in it and store all that data in a variable called data. So go ahead and run that, and that runs fine. And now we can print the contents of the file using print data. And you should see after we run this, we get this is a test message. So that's worked fine. So we've read from a file. Now, interestingly, we'll see what happens if we try and read from the file again. So we're going to do the same line again, data equals test file dot read, and then we're just going to print data again, and we'll see what happens. Now this time we don't get anything, which is a bit odd. We might think, oh, why have we got nothing? Surely last time we got this is a message, and that still exists within the file. So why haven't we got any information, any text? And the reason is Python remembers what position you are at in a file. So when we use read for the first time, we read all the way up to the end of the file. So when we call read again, we are already at the end, so we get nothing. It's kind of like a bookmark. So Python moves the bookmark in the file up until the point it read from. So when we read from the file again, the bookmark's already at the end. So when Python goes to read to the file, it goes to the bookmark, sees it's at the end, and doesn't read anything because there's nothing left to read. However, Python does allow us to change where the bookmark is using the seek method. And the seek method takes two arguments, offset and whence. So offset determines like how far backwards or forwards we want to move the bookmark. So we could say move the bookmark forwards 5 steps or backwards 5 steps. And whence determines from where we want to move the bookmark. So we can either move from the start of the file, from the current position of the bookmark, or from the end of the file. Now for text files, we can only move it from the start of the file due to how text data is processed and stored by Python. So what we can do is on our file, we can do test file C 0,0, and that'll tell Python to kind of put the bookmark back to the start because we're going to say go 0 steps forward from the start of the file. So that's going to put the bookmark back to the start. So go ahead and run that. And now we can go ahead and read the data in and print the results again. So to make this quick, I'm just going to put print test file.read. hang on, typing issues. There we go. And we can see it reads the data and prints it again as we expect. We could also seek to the middle of the file. So for example, we could do test file.seek. And let's say we want to go 10 steps into the file, 10 characters into the file from the start, and then we will print the result of that. There we go. And we run that. And we can see we just get test message. We've gone 10 characters into the file, and we just return the remaining characters. So the last thing we need to do is once we're done using a file, we need to make sure we close it. And the reason for this is because while Python has got the file open, other programs on your computer won't be able to look at it. It won't be able to access it or process it. So often, once our program is finished with the file, we want to close it so that it kind of appears back in the directory. It saves all the changes to the disk, and yeah, other programs can access it and use it. So we go ahead and close the file, and that's all good. Now, one thing to note is if we try and read from a closed file, so if we do test file read, we're going to get an error that's just going to tell us that we're doing an in-act operation on a closed file. It's basically just going to say you can't do that. The file's not open. And this is useful to be aware of because sometimes you might forget to close the file or you'll close the file too early, and then you'll try and do something like this, and it'll give you this error. So just to be aware of that, if you do see that error, it means the file's been closed. So you need to go back up through your code, kind of run through what it's doing, and see at what point it closed the file before it's supposed to. Now, instead of using file close, we can also use with as operators. And this allows us to it allows Python to do some of the legwork for us in terms of opening and closing the file. So the syntax for this is as follows. So we put with and then we put open. So the command to open the file, data slash test.txt, and we'll put it in read mode again. And then we pass like a variable name. So what this is going to do is it's going to open the file and then kind of store it in this variable test file too. But it's going to indent all the code from this point onwards. And then once we go out of the indent, it will automatically close the file. So it's kind of a nice way of kind of showing in your code how long the file's open for, kind of where the scope of the file in your code, if that makes sense. So that we can tell that the file opens when it says with open the file, and the file closes once we unindent the code. So we can do stuff whilst we're in this indentation block. We can do stuff like we can print from the file, we can print the data from the file, and then the file will be automatically closed after we finished. And obviously the variable won't exist after we finish. So we can just go ahead and do that. And you can see, why didn't it open it? Oh, hang on, yeah, wrong name. There we go. So we go ahead, run that. And you can see we get the result we expect. It's read the file, and then it's also going to go and close it. So if you only need to like basically open the file and grab the data, this is a great way of doing it. It saves you having to do an open method and a close method. You just do this simple statement, and it's getting nice and quick. So we've kind of covered reading text files. What we're going to have a quick look at now is reading binary files. So on your computer, all data is going to be stored as ones and zeros essentially, or as like numbers basically. So in terms of like text files, in terms of files that aren't text files, they'll be stored in this format as ones and zeros. I mean, text files are also stored in ones and zeros, but Python kind of interpret them quite quickly. So let's say you wanted to open an image file. Chances are, unless you're using a special library, which we're going to come on to later, Python won't be able to open it. It will open it, but it'll look a bit weird. It'll look a bit odd because it's just essentially data. So if you need to process binary files, what you need to do is you need to use the B mode in the open method, which will tell Python that we want to process a binary file and we're expecting to get binary data. So for an example of this, we're going to reopen that text file, but we're going to open it in the binary file. So we're going to do open data slash test.txt. And then we're going to put RB, so read and then binary. So Python knows this is a binary file. Then what we're going to do is we are going to print. We're going to store the data in the data variable. And then we're going to print data. We're going to print the first character of data. So data will be basically an array. So we're just going to print the first element of data, and then we're also going to print the type of data. We go ahead and do that. And we can see that the first line gives us the data in the file. This is a test message, but it appends this B to the front and puts in these apostrophes. And the reason it's doing that is Python is telling us that this is binary data which Python has been able to interpret as text. And you can see that when we print the first element of data, data 0, we don't get capital T, we get the number 84. And this is because the number 84 is kind of the number representation of T on the computer. So we're not printing out the text data, we're printing out the binary data, we're getting those numbers. And lastly, you can see when I do type of data, you can see it's a bytes object, and that's telling us again that this is binary data, not text data. So if it was text, it would probably be a string, but because it's not, it's because it's a binary array, we get the class bytes. Being aware of this is very useful for any processing any file type that isn't primarily text-based, such as images or audio. And binary files also allow us to seek from the current position or from the end of the file. So as I said, with text files, you can only seek from the start. Well, because binary files, because bytes are a set number of each byte a set length, Python is able to seek from wherever in the file. So we could do something like bin file dot seek 5 characters. So we go backwards 5 characters from the end of the file. So we're going to read the last 5 characters in the file. And then we could just print bin file.read. So we're going to print out those last 5 characters in the file. And then I'll just close the file as well because we'll be done with it. And we'll go ahead and run this. And we can see that it prints out the last 5 characters from the file. So we went to the end of the file and then go 5 characters backwards and printed out those 5 characters. So yeah, with binary files, you can seek from the start, where the bookmark currently is, or the end. Whereas with text files, you can only seek from the start. So just another thing to sort of be aware of. Okay, now that we've covered reading from files, we need to look at writing to files. So obviously, it's useful to be able to read data, but it's also very useful to be able to write data and save data to the disk, especially if your application is doing any sort of important processing that you want to save results of. So this can be done using a different mode with the open function. The possible modes are kind of listed below. The main ones we're going to focus on are W and A for write and append. So what we're going to do is we're going to, using Python, create a file called test2.txt. So I've already got one here, but I'm going to delete it off of my computer just so you can see how this works. So what we're going to do is we're going to write file equals open. And this time when we call open, we're going to give the path where we want the file to be. So data slash test2.txt. And now we're going to put W instead of R. And what this is going to do is we're going to tell Python that we want to write to the file. And what that means is Python, if the file doesn't exist, then Python is going to create the file for us. So we don't even need to create the file. Python's going to cover that for us. And while we're at it, we're going to also add some text to the file. So we're going to do write file.write. I love writing files. There we go. And then we'll go ahead and close the file at the end there, just because it's good practice. So go ahead, run that, and we can see that it created this file test2.txt. And if we look at it, it says, I love writing files. That's what we wrote to the file. That's what we told Python to do. So excellent. It worked well. So let's go ahead and do that again. But this time we're going to use different text. We're going to try something different. So let's do that. I'm just going to change it to I love reading files. Run that again and see what happens. Now, if we go back to test2.txt, we can see that it's overwritten our previous file and changed it to I love reading files. So this is something to be aware of when you're using the W mode, the write mode. Python will overwrite any file that comes across. So if the file exists with the same name, Python is going to delete that and overwrite it with the new data. Now, sometimes this is useful, but sometimes we want to keep the previous data. We kind of just want to append to it. We want to add to it. And we can do this using the append method instead. So we're going to do the same again, but instead of W, we're going to put an A here for append, and this is going to add text to the end of the file. So we know there's I love reading files in there, and now I'm going to put and writing files. And what it should hopefully do is it should open up test2.txt and it should append the following case to the file. So if we go ahead and run that, all runs fine. We go back to test2.txt. You can see that it says, I love reading files and writing files. So we've appended this text here to the file without getting rid of the previous stuff. So that's kind of the gist of reading and writing files. If you want to use R to read, W to write and overwrite, and A to write and append. So yeah, just be aware of those distinctions because otherwise you might accidentally delete a file you don't want to, or accidentally append to a file that you actually want to overwrite. So yeah, just make sure you make those distinctions in mind. Okay, now sometimes we might want to read a file in parts and process each part separately. So one example of this is comma separated value files, which are kind of sort of data table files in a sense. So an example would be it's essentially just a text file with the first line will contain column headers. So for example, like name, student number, course, and then the subsequent like rows will be the data. So for the name, each sort of row has got a name, a student number, and a course that that person's on. It's kind of like made up data about a student. What we'd want to do in this case is we want to read one line at a time and probably store it. So you want to read a line, see who the student is, and maybe do some processing on that line of data, and then read the next line. We don't want to read everything at once necessarily, because the data is kind of split up into this line by line format. So what we can use is we can use the read line method to do this. It will read one line at a time and allow us to kind of process the data in a line by line format, which would be very useful. So firstly, we're going to open the testdata.csv file. So if I open it up here, you can see there's this simple CSV that just has a name and a society for kind of all the people running this course. So the first thing we're going to do is we are going to open this file up. In read mode, and we're going to call it an R plus mode, and this is going to allow us to read and write to it, just so we can demonstrate kind of both aspects. So we'll go ahead and run that. And the first thing we're going to do is we're going to store the headers of the file in a list of headers. Headers equals, and then what we can do is we can do CSV file, got read line, and this is going to read the first line. So if we look back at the file, the first line is going to be these two headers, name and society. We're going to read the line, and then what we're also going to do is we are going to split the string by comma. Because we've got two headers, what this will do is it will kind of split the two headers into two separate positions in the list. So it will give us kind of the headers in an array form rather than just a long string. So this is really useful when dealing with CSV data, is the data is comma separated. So if you split by comma, you're just going to get the elements of the data in an array, which is usually really quite helpful. The other thing I'm going to do is I'm just going to remove the new line character from the line as well. So if you look in the test.csv file, although we can't see it, there will be a special character at the end of this line that says go on to the next line. Now we don't actually really need that in the data in the array, so we're going to get rid of it. So we're going to get rid of it so it doesn't affect anything. So we've done all of that. I'm going to print out headers as well just so you can see what it looks like. Go ahead and run that. And you see it gives us that array of name and society. So we've taken the line, we've split it by comma, we've removed any unnecessary new line characters, and we've put it into this helpful array. So the next thing we could do is we can put the data in the dictionary. So given a name, we can get the society they're in. So this is like an example of how you might want to process a CSV file. So what I'm going to do is I'm going to go ahead, because the code's a little bit longer, I'm going to copy it from the complete notes and sort of walk through how it works. So what this code is doing is we kind of create this dictionary called DataDict, and then we do the same line we did before to get the headers. We read the line, we strip out any unnecessary characters, such as new line characters, and we split by comma, and we read that line in. Now, what we do next is we check, is the line equal to nothing? If the line's equal to nothing, i.e. an empty string, that means we've got to the end of the file. So we can stop reading and we can just print out the DataDict as it is. If the lines are not equal to nothing, that means there's still data left to process. So we read in that data. If the data is nothing, we finish. If it's not nothing, then we go ahead and process the data. In this case, that's adding it to the dictionary. So we take the name, and we use that as the key for the dictionary, and we use the society as the value for the dictionary. And then we go ahead and read in the next line, and then obviously this is going to go into the while loop and check, is the line equal to nothing? So it means when we get to the end of the file, the while loop's going to see that line's equal to nothing. It closes the file because there's no data left to read. So I'm going to go ahead and run this, and hopefully it should work. And there we go. We get all the people kind of put into the dictionary with their name as the key and the society as the value. So if I then go ahead and do print data dict and then Alistair, it will tell us, hopefully if it runs, that I'm in Warwick AI. We could do it with Keegan as well. So we can see Keegan UWCS. So you can see we're able to take the data from the CSV file and put it into our code in a format that's really handy, because now we don't have to bother with like searching through the whole file. We can just call the person's name and we can find out the information about them. So this is really quite helpful. So hopefully you can now you can see that you can access the data in the CSV file using the dictionary. And yeah, this is just a simple example of how you can use Python to parse CSV files into data structures that are more useful, that allow us that sort of flexibility to process data and to index data without having to spend ages searching through it. The other thing we're going to try is writing a new line to the file. So we're going to add a new entry to the file. Now, Python doesn't have a write line method. However, we can just use the write method to write a new line by putting the new line character at the front of our string. So I'm going to do CSV file.write, and then I'm going to put the new line character, which is /n, and then I'm going to put Ollie. He's the president of Warwick AI, and then I'll put Warwick AI. So we're going to add someone else's data to the file. And then after we've done this, I'm just going to go ahead and close the file. So I'll go ahead and run that. That should hopefully run fine. And then if you look at testdata.csv, we can see that Ollie WAI has appeared there. So we've written a line to the file. So that's one thing to bear in mind when you're writing lines to files. You can see that you need to write it like you would text, but just prepend that sort of new line character at the front to make sure that it appears on the new line. So that kind of covers us for reading and writing files. And we also saw, covered CSV files as well. So now we're going to have a quick look at command line arguments. So command line arguments are used when you have programs that you run from the terminal or from the command line. And they're passed into the program, and they can kind of either be used to pass data into the program, or they can kind of specify sort of arguments or conditions that will affect the behavior of the program. So I've got a little example here, which I'm going to show you. So Python is like a command line argument that you can call. You can call like the Python command, Python program, and it will run Python. So one thing we can do is you can do Python-C, and then we can write some Python code. And what's going to happen when we run this command is under the hood, the command line is going to run the Python code and print the result. So here we're saying Python-C print hello. So hopefully it will print hello. We could change the text in there. We could change it to hi, and it would print hi. So you can see that runs the Python code. Now the other thing we could do is we do Python-C. And what this is going to do is this is going to give us a version of Python that's installed on my machine. So you can see here it says Python 3.8.8. So although we use the same like initial command as Python, by specifying the -c or the -v, we were able to kind of modify the behavior of what the command was doing. We were able to kind of change what it was doing to give us what we want. And we can use a similar sort of technique or similar sort of idea in our own programs. Now, I don't have time to really go through a massive example, but I'm going to go through like a sort of a small example. If you want to go ahead and like look through the notes and read through the notes, I'll give you a good example of like the different things you can do with this. But what I'm going to go ahead and do is I'm going to just create a new file. I'm just going to call it command line args1. Hi. Okay, so the first thing we need to do is we need to import the system library. Now, I'll cover libraries in a second, but what this basically does is this allows us to retrieve those command line arguments when we give the command to run our script. Now, what we have in here is we have all the command line arguments that are going to be stored in this variable called sys.argv. And this is actually a list. So what I'm going to go ahead and do is for our program, I'm going to go ahead and print out this list. So we're going to save this, change directory to week 4. And what we're going to do is going to Python, we're just going to put the name of the file, command line arguments, 1.py, run that. And you see it gives us that list with only one thing in it. And that one thing there is the path to the file. So the first argument in the kind of command line arguments is always going to be the path to the Python script you're running. So you'll always have at least one argument, and that's what it will be. So let's say we want to add another argument as well. Let's say you want to add a person would put in their name. So we're going to store that in name equals sys.argv1. So when the person puts in their name, we'll store that name in there, and then we're going to print out a simple greeting. We're just going to say hello, and then name. So that's going to print out a nice greeting to whoever runs our program. So go ahead and run this again, and this time I'm going to put in my name, Melissa. We run that, and we can see we've got an additional argument here in the list, and then it prints hello, Alistair. It's taken in that data, it's processed it, and it's given us the result we want. Now we could also add an optional argument as well. So let's say we want to add the optional argument -u, which will make the name uppercase. So what we could do, and because this is optional, we might not have to specify it. So what we're going to do is we're going to put in a condition that says if the number of arguments we've got, sys.argv, if the length of this is greater than 2, i.e. there's more than just the basic 2 file path and name argument, then we know that there's going to be a third argument. So now we can check, is the third argument equal to, and I'm going to call -u for uppercase. And if that's true, what we're going to do is we're going to say name equals name.upper. And what that's going to do is that's going to convert our name to entirely uppercase. But notice we're only doing this if there's that third argument and if the third argument is equal to -u. So I'm going to go ahead and save that, and we'll run this again. So firstly, we'll run it without the argument. See, it runs just fine. If we run it with -u, it puts on my name in uppercase. And if we change it to like -y, it's not going to run, it's not going to put it in uppercase because we specified it was only if you put -u. So yeah, that's kind of a basic introduction to how command line arguments work and how they can kind of change the behavior of the program. If you want to have a bit more of an in-depth look, read through the notebook and also have a look at the command line args file here. This is kind of an example file that I've created. There's instructions in the notebook on how to create this file and how to code it. That will kind of show you a little bit more of like how command line arguments work. So just to give you an example of this file running, it's very similar to the example I just did. However, it will take in also a couple of additional arguments. It takes in -u and -r, and R will reverse the name. So we can put -u and get my name in uppercase. We put -r and get it backwards, and we can also put both and get uppercase and backwards, and we can put them in either order and get the same result. And we can put no arguments and get what we expect. So you can see if you have a look through this script, you'll be able to see a lot of ways in which command line arguments can kind of be used and used in really a nice way where the user doesn't necessarily have to put in like the arguments in a certain order. They can just specify what they want in any order they want, and the program will take that and they'll deal with it, and it will give them the result they want. So that's like a really nice bit of functionality that I'd recommend having a little play with. So yeah, I'm just going to scroll through the notes to sort of explain all of that. Okay, so the last thing we're going to cover this week is libraries. So we've already used a bit of libraries. We used it for the sys library to get those command line arguments. However, it's quite useful to know exactly what they are. So libraries are a bunch of classes and functions related to kind of certain functionality or a certain subset of tools we want to use. So the sys library allows us to interact with the system, and that's why we can get the command line arguments from it. So libraries are often like they're kind of subsets of code, subsets of functions that are really quite powerful and save us a lot of time because we have to write all this code ourselves. So to use libraries and to install them, we use this thing called pip, which is kind of like a Python sort of package manager or library manager. So yeah, you can go into the terminal and you can use like pip help to see all the options. But the main ones you probably want to know about are pip install, and then library name, which will install a library, list, which will list the installed libraries, and pip uninstall, which will uninstall the library, which is sometimes useful to do if you need to change the version to a better version, or if there's incompatibility between different libraries. It's useful to know how to uninstall them as well. So what we're going to do is we're going to install a fun little library that allows us to put emojis in our code, just because it's a fun example. So firstly, I think I've already got the library installed, so I'm just going to go ahead and uninstall it quickly, so I can show you what it looks like installing. So the first thing we're going to do is going to go pip install emoji, run that, and hopefully we should see that it will find the library and hopefully install the library. Finger crossed. There we go. So we're downloading the library, and then hopefully we'll be able to use it. So pip will just take a bit of time building the library and sort of setting it all up. And there we go. So it's a successfully built emoji. So this means we'll be able to use it in our code. There we go. Excellent. So that's all done. So then what we can do is we can import the library. So just in the previous example where we did import sys, we need to tell Python we want to import the library. So we can telling it we want to make reference to like things from this file. We want to make reference to functions from this library. So from here, we're going to say from emoji, import emoji. So we're going to import a specific function from the library, which will allow us to put emojis in our code. And then what we're going to do is we're going to do print emoji's thumbs up. So this is going to hopefully print the thumbs up emoji as specified in sort of that text there. So you go ahead and run that, and it prints the thumbs up emoji. So you can see this is quite a fun little example of showing us, how libraries work. We can use a library and import a library to get this functionality that allows us to put emojis in our code. But also, there's many, many libraries that allow us to do many, many things. Um, so yeah, lots of libraries have documentation web pages online. So if you import a library, it's very useful to check that documentation just to see how various functions work and what arguments they take and what sort of outputs they give. So you're aware of how to use it in your code seamlessly and how best, kind of what the best practice is with using the library. And yeah, once you can use libraries effectively, a lot of cool functionality becomes really quite accessible. Libraries can allow you to do anything from running web servers to interacting hardware to training machine learning models. So literally anything you want to do, chances are someone's already written a library to do it. So it's a good idea to get used to playing around with them because it saves you so much time. You don't have to write any of that code yourself. You can use someone else's code that's already been written. It's been tested. Um, so yeah, it really allows you to explore the possibilities of Python, and really just like kind of test the bounds of your imagination, what you can do. So yeah, really do have a look at libraries, get used to them, because they'll be very beneficial for any sort of future coding projects you take on. So I think that just about wraps up this week. All the relevant files will be hosted on the UWCS Google Drive. So yeah, I hope you've enjoyed, and yeah, I hope to see you at one of the future weeks of the course.